I'll start from here. Have you ever read this quote from Richard Feynman? I kind of see this very analogous to whatever we do in software development, because even though we work on like awesome language, during complete language, there is human emotions on part of it. That causes crashes, that causes everything. So it kind of relates me to there. And overall, when I see observability, I kind of relate to this concept like underneath, it's just developers building something underneath. They do have feelings and emotions, and that could lead to crashes, and observability helps you to overcome that. I mean, like this talk will be based on that, right? So a long time ago, when Java 5 and Java 6 were there, struts and Tomcat, I used to write code, and this is how my e-commerce application looks like. Everything is factored into smaller components, and I just built some modules around it. This was not Java 9 modules, but again, like everything is built, very cleanly architected. I was so proud when we launched this first application. And I could straight away, this is a monolith, that's the picture. I could straight away answer, is it working? Yes, it's working, because my application is running, I could see the logs. Yes, it's working. Why it fails, or how, when something fails, why it fails. I could very easily find out what is the reasoning that has happened. It's just one single log window for me, and fortunately or unfortunately, I need not have big resources or scale that application much faster, so I could easily reason why it fails and then fix it. And when I have to mitigate it, it's very easy. I just roll back to the previous deployment. That's basically it. Like, I don't have to worry about anything else. I just fall back to the previous deployment, because the previous deployment should have been working. And for me, during that time, monoliths rock. It basically helps me to answer everything. I could understand how systems work. That was great. And when an issue comes to me, the first thing, if you take a time axis around with it, the time it takes to identify issues is time to detect, right? Like, this is TTD. And in terms of monolith, it's in hours. Like, I could find an issue if it happens, if it is in a while. Within hours, we could find that issue. And within time to mitigate, within minutes, I can fix it. The fix is very simple for me. It just roll back and redeploy everything again. So I can do it in much faster scale. And then this thing came along, microservices. And it came with a lot of promises, right? Like, it says, like, it's a distributor. Like, you can have multiple team people working in different technologies, and it's completely distributed, so you can go ahead and deliver these things. And it also said granular scalability. This is one of the biggest features for me. Like, I could scale my application irrespective with the traffic that the application is receiving or the parts of the application is receiving. So it was fascinating for me. And then the final thing was fault tolerance. It came with all the promises. Like, when a service fails, you could actually isolate that thing completely away and do it. How many of you believed all these promises and embodied into microservices? Okay. One person believed the promise. That's good. So I find out, like, I have my application. I want to convert into microservices. As a natural developer, I want to get in the hop train. And I went ahead and designed the system, saying, like, okay, these are my different services. All those individual components that I had in my previous application, I moved into a different service. And everything is connected to an auth service for authorizing and authenticating my request that flows between those services. I felt, wow, this is nice. Let's go into production. And that scaled very quickly. And I had lots of services, lots and lots of resources hogging up my memory. My application definitely grew. I started from 10,000 people to millions and billions of people. Again, it's a fictional application, just to be very clear. But it had billions of users. With that, my scale also increased. So now I went back and asked the same question. Is it working good? Can we answer that? Straight away, by looking at few logs? No. Why it fails? Which part of the service fails? I don't know. One answer I always fall back whenever somebody comes and asks me why this service fails or why this particular thing fails. It's definitely not my code. Somebody else written it. That's their bad code, right? And can I mitigate it? I can mitigate it, but it depends, right? Like, I need to have more data and more information to make sure I can mitigate it. In this world of microservices, the time to detect is actually few days. I've seen applications or people worrying about some issues, and they did not even detect that particular issue. It took a long time for people to understand what is the issue. And it also, time to mitigate also increases to few days. And in terms of, like, it's going to take longer for you to mitigate a particular piece in this world. And we always want to reduce this timeline, right? Like once you reduce your time to detect and time to mitigate, fortunately, if you can automate your time to detect, that's where observability comes into picture. So that is the talk, seeing through the fog, mastering observability in microservices. We will go through that. I'm Sendil. I'm an engineering manager at Uber. This is me. I run on coffee, and I love programming languages. I tend to learn a lot. And I'm a very, very big procrastinator. In fact, the slide was done just before the talk. So expect some mistakes there. This is another thing that was fascinating. I read it on the Building Reliable, Secure and Reliable Systems book. Every system fails. And connecting this back to the Richard Feynman's code, because humans developed that. So every system will tend to fail. Do you folks agree? Is there anybody who has built a system that never failed? I don't see anybody, hopefully. I'm catering to the correct audience. So, but the concept of like everything will fail, of course it's going to fail. So I want to measure the internal state of an application by understanding how it outputs it. What are the outputs that comes out of the system? How can I understand how the application works? And that's basically what observability is. It's the ability of me to understand how a system works without even knowing anything about the system. Consider a black box that emits events. We call it as heartbeats. And listening to those heartbeats, how can I make sure my system works good? And all the things that depends on the system works good. And I would categorize observability into 3 types. The basic one, which actually tells when some errors happen. Like you have a standardized way of error handling. You can understand why a system fails. Is everything working fine inside the system? Or you can automatically detect whenever an issue pops up. This is a basic level of observability. The next level is a good level where you actually understand how a user goes through, what is the journey of a user inside the system, and how you can fix it. And I call the third stage as magical, which actually helps you to improve on what you do. Like you observe signals from your system, with that you can categorize it and also build new features on top of it, understanding how your users use the system. These are the 3 levels. Does anybody here works on a magical system observability yet? The maturity of magical level? Okay, basic? Okay, we have a few people. Good, nice. So fundamentally, all this encompasses into one simple thing. It is going to reduce the time to mitigate and time to detect. And that is basically what is a problem that observability will help you solve, mostly. Because user experience is equal to business growth. I'm also a JavaScript developer, so that's why you have triple equals to there. But again, like it directly depends on business growth. So what observability encompasses of? You could see multiple things, but the 3 major things are logs, metrics. Metrics comes up with alerts and events. And the third thing is traces. These are the 3 basic pillars or components of observability, any observable system. Along with that, you need 2 more things, visualizing all those things, and also querying. This is actually common across all these 3 pillars. So this is what a basic component of observability is, and this is what we are going to see today. So even before we go and jump into each of those boxes, what we need to measure. Anybody, like for an application, what you would like to measure? Sorry? Response times, yeah. Success rate, great. Somebody learned about golden metrics, yeah, sorry? Amount of errors, yeah. Throughput, yes. Awesome, so most of the folks who have answered it, it kind of falls into the golden signal spectrum for any application, yes. And let's take a arbitrary application. For me, the measuring part is like, what is important for the team, org, and the company. That's how I slot it across. And I want to debug when things go wrong. When things go wrong, I need to know, and also I want to debug it. I want to have an uptime of 100%. Yeah, I'm a human, I understand that I cannot achieve that, so my application can have 10 minutes of downtime. And I need to know when my application is down, or when part of my application or part of my services are down. I want it to be responsive, I need it to be very fast, and it also should have to give output. And my API should have like 250 milliseconds latency. And I understand things go bad. I make myself calm. I don't have to too much worry about I need to be perfect, and that's where the 10-minute downtime and some error budgets that I'm going to have are going to help me with. So these are the things I want to achieve in a good observable system. So let's see one by one. How do you debug your system when something goes wrong? Logs, yes. Any other?
Reproduce.
Sorry?
Locally.
Locally reproduce, yes. Good. Debugger, nice. Yeah, unique exception codes. That also makes sense. Sorry? Ooh, okay, what is that? I don't know that. Okay, heap dump, sorry, okay. Okay, I heard IP dump, so I don't know what was that. Okay, cool, awesome. That also makes sense. So you actually try to replicate it in your local and try to figure out, you get the logs and figure out, and of course, like when you want to, at a higher scale, when you know a particular service is going down, then logs can be helpful for you to understand what is happening. Logs are nothing but detailed record of events of time, so you can actually go through that record, find out if you have a good debugging or good logging infrastructure in your company, it can help. Logging can be structured, semi-structured, or unstructured. We are living in an AI world. I don't want to worry about semi-structured and unstructured. Structured logs are great. Consider these as JSONs. It has all the metadata attached to that log, so you can actually go and send your message. You can follow a schema to the entire company. These logs are very, very easy to search because there is an indexing that happens based on the structure that you're providing. And it is also much faster. So for example, if I build a logging system, which is basically like whenever I do something over there, my application emits logs. And these logs are captured in a queue. It can be a Kafka queue or something like that. Whenever we talk about queue, always understand there is a loss because Kafka queues are not 100% perfect, so there will be some losses there. And then I have an ingester. It can be a log stash or something like that. If you have worked on ELK stack, you would have remembered ingester, which ingests all the logs that is coming towards it. And then it indexes those logs, which helps us in querying and running fast queries. And once you index it, the two components that you'll see in all the systems is storage and visualization. So logs, traces, or metrics, you need to have a mechanism in which you store these things and visualize those things. Logs are very costly. How many of you have paid a lot of money to a cloud provider because you stored a lot of logs? Yes. See, logs are very costly. And it's also very limited time. You should not have logs more than like 7 days of data or something like that because it is very, very costly. You can also automate those things. Ingester, you can automate. You can add more information to it. You can automate the indexer part of it. You can actually automate the visualization part of it. So these are the areas where AIs can help you to improve better. So logs, it needs to be searchable. It should not have any information about a person or about a new ID or something like that. No personally identified information should be there. And you can use to debug. When you have a high system, like when you have a microservice environment, you should have a correlation ID. So correlation ID is like the same ID that is served with, for example, your session ID that can be used across multiple services. So if you hop across multiple services, you can actually see how a user journeys through with that correlation ID. So you can do all these things with logs, but you have to understand it has a very limited time and do not pay more for it. This is from GCP. The logging environment that we use in all the microservices world is something like this. It's searchable. It can be catered to a particular project or particular service and things like that. It's really easy to do it. This is nice. Logs are great, but this is good for a particular service. If you have one service, if you found out the problem for that service, you can use logs. The next thing that you can go is tracing. Tracing is basically distributed tracing. Anybody used tracing here before? Jager? Yes, we have a few folks using it, right? So it is very helpful on that spectrum. So distributed tracing is built for microservices. And in this world, if going back to my application in this world, when a user wants to go and purchase something, when a user places an order and pays for that service, the user has to hop between user service, auth service, order service, payment service. They have to hop between all these services, and my application should go and cater them. But the problem might be happening between auth and order or auth and user. It can happen at any place. So I need to understand, and that's where distributed tracing will help you. If you just take a look at distributed tracing at a very high level, this is how the traces will look like. and traces has trees and spans. I'll go through them a bit, but this is how my traces look like. It is created based on a particular origin, and then it caters down as a waterfall, so you can understand which service takes more time and what you need to fix it over there. And human brains are visually great, so you can also have this topological structure, which kind of tells you where the problem, what are the problems that you're foreseeing, and you can compare it with your metrics. Again, if you take tracing system, it's going to be very similar to what we have seen on logging system, but the difference is like you have something like Agar collector or an OpenSDK telemetry collector or things like that, which goes and captures this information, puts it in a queue, store it somewhere, run some jobs on top of it so you can optimize those things, query it, and visualize it. So that is basically what's going to happen. Traces includes list of spans in it. So a span is basically, every line in the trace is called a span, and a span basically consists of name, a tag, time, and reference to the services. So basically a name in the sense of like a service name, tags like, hey, how this is going, what is happening. Time here generally talks about latency, the start time and end time of the request, and the reference to other spans, so it can be interconnected and chained as a directed acyclic graphs. If you take a look at each of these traces, every trace will contain a context attached with it, so this context will also help you to understand how the traces progress. Remember the correlation ID that I was talking about in logs? That correlation ID will also live over here, so it can be passed and trickled down so that tracing can aggregate them together and show it. And traces are very good. For example, in distributed system, if you have used service mesh, tracing comes out of it. It gives a centralized logging, and time in and time out, whenever I go into an incident management, the best thing that can come up is traces. Because when you ask why something fails, what is the reason, tracing actually gives you an answer. The root cause analysis with tracing is really important and really easy to do. It gives granular visibility of where the problem lies when your services talk with multiple services. It is very good for debugging, as I said, and it also good for understanding your architecture footprint. Like when you have massive scale, like millions of services running, if you want to understand how your systems look, how the topology of your system looks, tracing is the best tool that you can have that can give that visibility for you. All right, so I want to debug, so I have logs and traces. I can use logs and traces to debug things across. Let's go into the other thing. What do you call these two things? For example, what do you call 10-minute downtime there? Sorry? SLA? Kind of, yes. SLA is an agreement, yes, of course you can say. Sorry? SLO, yeah, you can say that. SLA is outside, SLO is inside. That's how I see it. I call it as an availability, right? And these availabilities, and this is latency for me. And this is for my application metrics that I have. And these two converts into SLI, which is service level indicators. These are the metrics. So indicators are basically the metrics. Objective is basically higher level to the metrics, which is basically you have internal target inside your company. And SLAs are something that you give it to the external world. So I have these two things, 99% availability and 250 millisecond latency, and I call them as metrics for my application. And this is where metrics comes into picture. So metrics is basically how I measure a state of the system across time in my application. Metrics can be a counter. It can be like 1, 2, 3 counter, gauges, or a histogram, a historical view of how things have worked. And you always compare metrics with the Grafana. Grafana actually helps you to visualize those metrics in a much better sense. And the common metrics that we can see is availability, server utilization, and whatever the golden signals we have talked about, error rates, throughputs, and all those things. They all encompass into metrics. And one of the key things that we need to understand is when you're talking about metrics, you need to define them during the design phase. How many of you have talked about metrics when you're writing your initial requirement document here? 1, 2, 3, yep. So it's very essential that you have to mention that, like when you're actually creating a new service inside your microservices architecture or just building your company from the ground up, you need to talk to them at the design phase, understand what should be your availability, what should be the error rate that you're okay with it, and things like that, because it helps us to move forward in a correct direction. All the metric systems kind of follow a similar structure. You have an application that emits heartbeats or signals. I collect them via queue. I transform and enrich the metrics. Because metrics are bland data, it is like counter, 1, 2, 3, or a histographic view. So you just need to transform that metrics into the structure that you want. This, you can do it on your servers. You unify these events, you have to couple them together, and you store them, visualize them. Again, you can use AIs here in application side, because when you build the metrics, you can just automatically build them with AI, just like adding a unit test to your application. And then you can transform, enrich, and all those things you can use AI that can help you to move forward in metrics. Metrics is collect them all. It's just like Pokemon. So you just have to collect everything that comes out of it. But it gives a very, very limited information to you. Metrics are really great for real-time verification. Every day when I start my work, I have to look at metrics dashboard to understand how systems worked for the last 6 hours or last 12 hours. And I could also hold longer data in metrics, last 30 days data, because then it gives me a much more flexibility of understanding how week-over-week data are working on. You have to continuously refine them. For example, today you can start with the system availability at 90%. Tomorrow you can increase that availability to 99.9%. You can do that 3 nines or 4 nines. You can continuously iterate and do that. There is also dashboards. Dashboards are really cool. And if you're starting your day in those dashboards, you feel like a hacker. I do feel that. You identified some SLAs. You collect those metrics. Is that enough? Sorry? Yes. That's what the next thing is. So we will start alerting on them. So you need to know when this thing happens. You need to understand how this thing gives an output, right? Like you collect metrics, okay, I'm fine. But if you stop there, your system is not observable, right? So you need to understand about when it happens. And that's where alerting comes into picture. Alerting is all about automatically informing you when something goes wrong. You cannot always go and see the metrics dashboard. You cannot always look on your logs to understand what happens in your system. So we have alerts. The alerts is basically this. You identify some SLIs, you collect the metrics, you monitor over them. Again, here, you can use AI tools, or you can use automated scripts over there to monitor them, and then you alert on top of it. So you can create alerts on top of it. Again, when you see alert system, it's an extension of metric system where you monitor, you compare with the baseline that you have, and if something is not correct, you page on them. How many of you got paged because of a bad deployment that happened on a Friday? Okay, 1? Cool. I got paged every day. Even before this meeting, even before this talk, I had 1 page. Alerts are great. Alerts help you to automate things. Alerts help you to understand when things go wrong. And it can make you to live peace because you know your phone will ring if something goes wrong. You can prioritize those alerts. The main thing that, as a team, what you have to do is, like, whenever you set up some alerts, you have to look at them periodically and reduce the signal-to-noise ratio. When you are having a lot of noises in your alerts, your team is going to have heavy burnout. So you have to reduce that. Try to figure out, like, how can I reduce that signal-to-noise ratio? Refine the alerts. Create runbooks. Usually when alerts come in, like in midnight or something like that, you might not have your full brain capacity to work on this because you'll be half sleepy. Create runbooks for that. Create a book that kind of helps you, like, if this alert happens, these are the steps to do. Very well define them. It kind of helps you to work during that time. Annotate all the alerts, figure out like what is missing, and things like that. All right, so you understood, like, we have alerts there, which kind of like made easier for you to understand, like, when there's an outage or something like that. That's great. So that's where alerts will help you. And the last and most important thing is you have to understand that things will go bad for sure. And when it goes bad, all you have to do is try to mitigate. Because early in the morning, you need not try to go and fix things, or late in the night, you need not go to try and fix things. You have to mitigate. Find out a way to mitigate faster, because that is most important for your customers, rather than trying to fix the problem all by yourself. Of course, you have to do it after. So we have seen these 4 stages, and each of these 4 stages, like, when you identify your SLIs, try to define them during your design phase. You have to know what is important to understand, and your company has to have its own way of finding it. You have to document all your SLIs, codify them if you can, and continuously monitor and modify them as you go in your life. Collecting metrics, it's very important to collect precise and track unique and avoid tracking unique identifiers. Metrics are a great tool for understanding what is happening in your system. This metrics are just showing the status of your services and things like that, right? Monitoring, it's defined based on your SLIs. Your SLIs always form the basis. You have to define error budgets, which kind of helps you to define the thresholds above which and beyond which you have to get alerts. And AIs will help, and your job here is to minimize the false positives. Similarly, on alerting, you have to, when things go against SLIs, you have to give an alert. It should be actionable. You have to classify them, have runbooks, mitigate incident before happening. That's basically what is needed. So as you can see, like all these pillars that we have seen, you can have AIs in all those places that could help you to make your life more simpler. And if you just summarize this, taking one step back, all the systems that we have seen forms or uses this kind of a format, right? So you have an instrumentation which kind of like gathers all the data. It takes in all the things that are necessary for you. And then you have a stream processing, which kind of like, it's a queue that we have seen in all the examples, where you put all those things and it collects them and then works on them. And then you have a storage where you store them. And finally, you have an experience layer, which kind of like creates an UI for you. Time in and time out, this is the exact replication what we need. You can pipe in an application, or an application can be an instrumentation layer. You just send all those events and comments inside it, process them, store them, and then visualize them. That could help you to understand how things are working. So this is my cycle. I called it this demand. With the limited Dutch knowledge that I have, I know that it means moon, so I'm trying to put it over there. So it is basically like from the lower end to the other end. So you detect. You have to detect when things go wrong, and that is your core observability nature, right? You have to find out when things go wrong. And when something goes wrong, you try to first mitigate it. You should not solve it. Try to mitigate it. You always mitigate your alerts first rather than solving it. After you mitigate, you go ahead and analyze what has happened. This is where your actual process of fixing things will come up. So you go and fix things. Artifact it, like once you have created that, try to create a runbook or try to create a record of whatever things that has happened. And once that is done, the second or the last biggest thing that I would say is like never repeat the same mistake again. So if you're actually fixing for once, let it be the final time you're fixing it, and then use that and do not repeat anything. Does it make sense? How many of you have had the same alerts a couple of times? Many times? Oh my God, okay. Okay, there are some fun stories there then. Yeah. All right, the best practices. Sorry? Okay. Okay. Okay, over and over. That's true, that's true. We are all humans, that's correct. All right. One of the major things is like, even if you put like analytically or like if you go and figure out like multiple studies that has been found, when you recover faster, your users are happier. If your users are happier, you prevent major accidents. That's basically what's going to happen. It's always mitigation first. That's what I've been telling from the beginning, right? It's always mitigation first, and recovery should be the fastest thing that you're doing compared to other things. So try to always prevent accidents, but you cannot do it 100% of the time. When it does not happen, try to recover from that accident, and that will really help you to move forward. And I mean, like, this is a fancy thing, right? Like, we have test-driven development. Why can't we just have observability-driven development? Again, like this basically defines the fact that you have to go at the beginning of stage to your design of your application and try to think in observable way. Try to figure out like what are the metrics that you need, what are the SLIs that you have, and how can you build your system from the ground up. This would technically help you to solve most of the things. And small incremental changes are the best. How many of you have reviewed a code that had more than like 10,000 or 15,000 lines of code change? 1, 2, 3, 4, 5, 6. Okay. Sorry? Reviews, yeah. So my favorite thing on doing that review is like I just close that review saying like, hey, create a different PR. That's it. And in my team, we have the statistics where we kind of follow how many lines of code each diff has and whether it's below 70 lines or not. If it is above 70 lines, any person who is going to do, he's going to have a difficult performance review. But again, like 70 lines is maximum. And you have to always ensure the number of changes that is happening is going to be very small. And also when you launch things, when you roll out things, that's why I love daily rollouts. Because when you do daily rollouts, the number of incremental changes that goes outside is also going to be very, very minimal. The minimum that you have that, it's the best thing that could happen for your company. And automation is your best friend. You could just jump in and add an automation here, everywhere, every point in that map, or every point in that architecture, instrumentation, storage, or anywhere. You can add an automation there that could help you to drive things much faster. It could also solve you a lot of problems. For example, when we were working on an UI-based application, we had this new system which kind of like, it's a web application. So in the web application, there's a lot of forms that a user has. And in all those forms, every interaction that a user makes, we need to capture an event. We need to capture a signal for that particular event. So we can actually automate that entire thing. So developers need not write anything. The moment you submit a code request, it's just like writing a unit test on top of it. AIs will come and generate. The LLMs can come and generate the automated script that adds events to it. You just have to define the schema, and with that schema, AIs can deliver those things. And there are a lot of tools that are available that could help you to do it. So use them. Automation is your best friend, and it can help you to scale much faster. Always measure, measure, measure things. Keep on measuring it, and try to optimize it, and that is what helps you to move faster in a microservices world. And finally, there is no silver bullet in running systems as well. It depends on your context, your application, and it depends on it. Okay, my GP always recommends paracetamol for me, so that's why it is there. And observability is key to understand what went wrong in the systems. It helps you to understand like where the main problem is, and then tries to address that problem. And that is what observability is all about. You can use tools like logs, metrics, and traces to understand where things go wrong, but you have to define and craft them properly in order to understand what went wrong in your systems. I think I'm a bit early, but that's it from my side. Thank you for your time. Thank you. I can answer any questions you have. Sure. Sure. Okay, I purposefully moved away from tools. I don't want to be a sales pitch and put up tools over there. But again, like for logs, ELK, Logstash is a better tool. For tracing, Jaeger tracing is best I've seen in the market. And along with Kibana and everything in the ELK will also work on logs too. For the dashboards, if I go just plain vanilla, Grafana is great, along with the metrics. I've used a lot of M3DB and Prometheus. Prometheus in first, and then M3DB next. It might be influenced by my company because Uber kind of like created most of the tools over there. I would have used the same thing over there in my personal projects. So along with M3DB, you pipe all those signals, and then have Grafana where you can visualize those signals. That helps a lot. Sorry, there was another person. Yeah. They are closely related, but they are not same terms. That's how I see it. Observability gives that view of how your system works. If I look at the topological structure of how my application works and where the problem lies, and if I figure out that, that's where observability comes into picture. But if I go a step further and connect all those things, and also infer something out of the data, that's where I call it as like magical level. When the observability goes beyond that level, then you can actually make sure that is an operational inside of your application, then you can get more data, and then you can define everything that comes out of it. Yeah, sorry, you had the question. Yes. Mm-hmm. Mhm. Yes. There are 3 or 4 things that I could say. One is like predicting, of course, like what the future will happen based on whatever I'm seeing now. That prediction AI does really a good job, so you can do that. The second thing is I don't need to analyze historical context to understand what my application is. Like when something goes wrong in my system, I need not go and say, oh, what happened in the last week data? What I have to do for that? I could use AIs to build that information for me and bring that information forehand itself, so I can use that to utilize more. So it makes my job easier in terms of searching and things like that. The third thing is like whenever I have an issue, I kind of go and have a runbook, right? That's where the runbooks come into big importance, because if we train a model with a runbook, you train the model so that it follows the runbook and brings all the data that you need, so that you need not, like it's not about historical data, but it can crawl through multiple systems. It can bring a tracing data, it can bring metrics related to that and pipe them together into a single view. That's the third layer where it can help. So it kind of like helps me in analyzing and understanding the problems better. You can use AI in multiple different directions, but this is what I felt very useful, because my systems are complex. In order to understand how things work, I have to train my AIs in the same way that I want to train it. Yeah. Yeah. There are a lot of talks that are happening. If you go to any open source platform and go and see how these tools are getting developed, there are a lot of things on Verge. But again, like you can train them with LLMs. It makes much more simpler to train them and then use them. Yeah. Yeah. Any other questions? No. All right. Let's get 8 minutes back.